Hey everyone, today we're going to dive into one of the most fundamental skills in Matlab, indexing. Seriously, getting this down is an absolute game changer for how you handle data. So let's get right into it.
So, the best way to think about indexing isn't as some scary, complex command. Just think of it as a navigation tool. It's basically the GPS for all your data, letting you go exactly where you want, whenever you want. And look, mastering this GPS is what unlocks everything else. It doesn't matter if you're cleaning up messy data from an experiment or running these huge, complex simulations. It all starts with being able to precisely select the exact piece of information you need.
Okay, so let's start with the absolute basics. How do you access just a single value inside a matrix? You know what? It's probably simpler than you think.
For our examples, we're going to use this simple 3x3 matrix. We'll just call it M. We're going to be pulling different numbers out of it to see exactly how this all works. Ready?
Let's say we want to grab that number 50 right there in the middle. The command is M2, 2. The syntax is always, and I mean always, row, column. So what we're really asking for is the element in the second row, second column. And boom, Matlab returns exactly what we asked for, 50. It's a perfect row-column lookup every single time. Simple as that.
All right, your turn. What about the command M31? If you follow that same logic, what value do you think that's going to give us?
Well, let's break it down. It's asking for the value in the third row and the first column.
Which is, you got it, 70. See, it's that simple. Now let's build on this idea with something that's way more powerful for working with real-world data.
Pinpointing one number is cool and all, but what if you need a whole chunk of data, like an entire row, or maybe an entire column?
For that, we use this super handy little tool, the colon operator. Just think of it as a wildcard. It basically means all, or give me everything, in whatever spot you put it in.
Now check this out, because this is where it gets really clever. The position of that colon changes everything. If you want to get the entire second row, you specify row 2 and then put the colon in the column spot. That's M of 2, dot. To get the whole third column, you just flip it. Put the colon in the row spot, so M of dot, 3. And the result for M2 square bracket? Well, it's the entire second row. We asked for row 2, all columns, and that is exactly what Matlab gave us.
And you guessed it, for M:3, we get that entire third column. This is so efficient. I mean, imagine you have a massive data set where each column represents a different sensor. This one simple command lets you grab all the readings from just that one sensor, instantly. Super powerful.
But wait, there's more. The colon operator is so versatile, it actually has another key function. It's one you'll probably use a lot, even inside your indexing commands, generating sequences of numbers. The syntax for this is super simple. It's just start, step, end. You tell it where to begin, what number to count by, that's the step, and where to end. It's a fantastic little shortcut for creating numeric factors. Let's look at a really easy case. If you just type 1:5, Matlab gives you all the integers from 1 to 5. Now notice we left out that step value in the middle. When you do that, Matlab just assumes you mean a step of 1. Okay, now let's specify a step. The code 2:2:10 means start at 2, count by 2s, and stop at or before you get to 10. And what does it give us? All the even numbers up to 10.
And get this, you can even go backwards. A negative step value, like in 10:2:2, just tells Matlab to count down. So here we start at 10, we subtract 2, and we keep going until we get to 2. It is incredibly flexible.
All right, let's wrap this up. We're going to recap the essentials into a handy little toolkit that you can start using right away.
So here are the 3 core techniques. To get a single element, it's row, column. To grab a whole row or a whole column, you use that colon operator as your wildcard. And to generate a sequence of numbers, you use the start, step, end format. Honestly, that's the foundation of pretty much all Matlab indexing. So, with just these simple tools, you now have this precise, powerful control over your data. You can navigate any dataset, you can pull out exactly what you need, and you can build the arrays you want. The only question left is, what are you going to discover first?